In the vast expanse of our solar system, where gas giants loom with their magnificent atmospheres, one storm reigns supreme: the Great Red Spot. This extraordinary feature, a swirling tempest of unimaginable scale, has fascinated astronomers and laypeople alike for centuries. Spanning more than 1.3 times the diameter of Earth, the Great Red Spot is a testament to the power and complexity of Jupiter's atmosphere. But what exactly is this colossal storm, and how does it persist in a world of swirling gases and chaotic weather patterns? Join us as we embark on an exploration of the Great Red Spot, unraveling its mysteries and revealing the remarkable forces that keep it alive. The tale of the Great Red Spot is one that stretches back over 350 years, marking a pivotal moment in the history of astronomy. The first documented observation of this gigantic storm was made by Giovanni Cassini in 1665. With the primitive telescopes of his time, Cassini gazed at Jupiter and noted a reddish oval feature, hinting at the immense complexities hidden within the planet's atmosphere. However, it wasn't until the 19th century that astronomers began to recognize the true nature of this enigmatic phenomenon. As telescopes advanced, the Great Red Spot emerged as a subject of rigorous scientific inquiry, igniting curiosity about its origin, longevity, and the dynamics that govern it. By the late 1800s, astronomers had begun to classify it as a storm, setting the stage for deeper investigations into its characteristics and behaviors. But what is the Great Red Spot, fundamentally? It is a massive anticyclonic storm, akin to a hurricane, that rotates counterclockwise in Jupiter's southern hemisphere. Unlike hurricanes on Earth, which draw energy from warm ocean waters, the Great Red Spot is fueled by the immense heat radiating from Jupiter's interior and the complex atmospheric dynamics at play. With a diameter exceeding 16,000 kilometers, about 10,000 miles, this storm is so large that it could easily encompass our home planet. The swirling clouds of the Great Red Spot are characterized by powerful winds, reaching speeds of up to 432 kilometers per hour, approximately 270 miles per hour, producing a spectacle of chaotic beauty. The vibrant reddish hue of the storm is thought to arise from a combination of chemical compounds, including phosphorus and various hydrocarbons, undergoing intricate reactions in Jupiter's atmosphere. Despite numerous studies, the precise mechanisms behind the coloration remain a tantalizing mystery, continuing to inspire research and inquiry. The structure of the Great Red Spot is complex and multi-layered. At its core lies a region of intense convection, where warm gases rise and cool gases descend. This turbulent motion creates a striking contrast between the lighter clouds above and the darker, deeper layers beneath. The storm is not uniform. It exhibits varying colors, shapes, and intensities, with features such as cyclonic bands, spiral arms, and turbulent eddies contributing to its mesmerizing appearance. The vertical dynamics of the storm play a crucial role in its longevity, as energy is continually exchanged between the layers. This intricate dance of gases allows the Great Red Spot to sustain itself against the backdrop of a constantly shifting atmosphere. To deepen our understanding of this incredible storm, scientists have turned to advanced space missions, most notably NASA's Juno spacecraft. Launched in 2011, Juno has been on a mission to unlock the secrets of Jupiter and its atmosphere. Equipped with cutting-edge instruments, Juno orbits the gas giant, capturing high-resolution images and collecting crucial data about the Great Red Spot and its surroundings. Juno's close encounters with Jupiter have allowed researchers to study the storm in remarkable detail, revealing the structure and dynamics that sustain this colossal phenomenon. The data gathered by Juno has not only enriched our understanding of the Great Red Spot, but has also provided insights into the broader atmospheric processes that define Jupiter itself. Juno's mission has yielded groundbreaking discoveries, including detailed maps of the Great Red Spot's temperature variations and wind patterns. By analyzing the thermal emissions from the storm, scientists can discern the energy distribution and understand how heat flows within this massive structure. Additionally, Juno has detected complex wind patterns and varying velocities within the Great Red Spot, highlighting its turbulent nature and dynamic behavior. These findings have not only enhanced our understanding of the storm, but have also provided critical data for refining models of atmospheric dynamics on gas giants. The information gathered by Juno acts as a window into the workings of planetary atmospheres, shedding light on the processes that govern weather systems across the solar system. As we study the Great Red Spot, we must also consider its future. Recent observations indicate that this monumental storm is gradually shrinking, a trend that has raised important questions about its longevity and stability. The reasons behind this reduction are not fully understood, but scientists suspect that changes in the surrounding atmospheric conditions and interactions with other storms may play a significant role. Will the Great Red Spot endure for another century? Or are we witnessing the slow fade of one of the solar system's most iconic features? Understanding the dynamics that influence the Great Red Spot's evolution is vital for unraveling the complexities of Jupiter's atmosphere and can provide parallels for understanding similar phenomena in other gas giants. The implications of studying the Great Red Spot extend far beyond Jupiter. By examining this colossal storm, scientists can glean insights into atmospheric phenomena on other gas giants and even exoplanets. The fundamental processes that govern the Great Red Spot, such as convection, rotation, and energy transfer, are likely applicable to a variety of planetary environments. Understanding how storms evolve and interact within these atmospheres can offer critical insights into the potential habitability of exoplanets and inform our search for life beyond our solar system. The Great Red Spot serves as a model for planetary weather systems, inviting researchers to draw connections across different worlds and explore the complexities of atmospheric dynamics in diverse cosmic contexts. The pursuit of understanding the Great Red Spot is a collaborative effort that unites scientists from various disciplines and institutions. As we delve deeper into the intricacies of Jupiter's atmosphere, researchers continue to explore fundamental questions about the storm and its implications for planetary science. What drives the dynamics of the Great Red Spot? How does it interact with other storms? What can we learn about planetary atmospheres as a whole? The answers to these questions are vital for piecing together the larger puzzle of cosmic weather, and they reflect our ongoing quest for knowledge about the universe. As we conclude our exploration of the Great Red Spot, we are reminded of the wonders that exist beyond our world. This colossal storm, a swirling testament to the power of nature, reflects the dynamic and ever-changing character of planetary atmospheres. Through continued exploration and inquiry, we are uncovering the secrets of the Great Red Spot and gaining a deeper appreciation for the forces that shape our universe. What other mysteries await us as we venture into the cosmos? The Great Red Spot beckons us to explore further, to question, and to discover the incredible phenomena that define our celestial neighborhood. As we continue our journey of exploration, may we remain ever curious about the intricate dance of the universe and the profound mysteries that lie just beyond our reach.